So good day ma'am, I am Matt Angelo Gigakot from BSEE 2B. So quiz number 2, fundamental of deformable bodies. Problem number 1. If each of the 3 nails shown on the figure below has a diameter of 4 mm and can be withstand an average shear stress of 60 megapascal, determine the maximum allowable force P that can be applied to the board. So given the number of nails, we have 3, the diameter of nails, we have 4 mm, and the average shear stress of 60 megapascal. So the average shear stress formula, P all over NA. So pi is equals to P all over N times 4 times pi all over 4 D squared. So our P is equals to shear stress times N, the number of nails, times pi all over 4 D squared. So P is equals to 60 times 10 raised to 6 Newton per meter squared times 3 times pi all over 4 times 4 millimeter times 1 meter over 1000 millimeter. So RP is equals to 2261.947 Newton. So convert it into kilonewton. So the result will be RP is equals to 2.262 kilonewton. So therefore, the maximum allowable force is 2.26 kilonewton. So for number 2, if the I bolt is made of materials having a yield stress of 250 megapascal, determine the minimum required diameter of each shank, apply a factor of safety 1.5 against yielding. So we have given tayo ng 30 kilonewton dito. So for the given yield stress SY, for the yield stress is equals to 250 megapascal. The factor of safety, we have Fs is equals to 1.5. So determine the allowable stress of stress is equals to stress Y all over Fs. So our stress is equals to 250, which is our yield stress na 250 megapascal all over 1.5, the factor of safety, is equals to 166.667 megapascal. So as I said earlier, given tayo ng 300 kilonewton, we have a summing forces of f of x is equals to 0. Apply natin yung equilibrium equation. So n minus 30 is equals to 0. So Rn is equals to 30 kilonewton. So stress is equals to F all over A. 166, our stress is equals to 166.667 times 10 raised to 6 is equals to 30, which are 30 kilonewton times 10 raised to 3 all over pi all over 4 times D squared. So our D squared is equals to 30 times 10 raised to 3 all over pi all over 4 times 166.667 times 10 raised to 6. So our D squared is equals to 2.2918 times 10 raised to negative 4. So for our D, square root natin yung 2.2918 times 10 raised to negative 4 will be our D. The result will be 0.015138 meter. So convert into millimeter. So our final answer for D is equals to 15.14 millimeter. So for the number 3, if the vault and the supporting bracket shown in the figure are made of the same materials having a failure shear stress of 120 megapascal, determine the maximum allowable force that can be applied to the bolt so that it does not pull through the plate. apply a factor of safety 2.5 against shear failure. So, we have a illustration there. Given tayo ng 80mm, 75mm, 30mm, and 40mm. And our P na vertical. So, first, we draw a free body diagram for us to easy to understand to solve a problem. So, our free body diagram, FBD, given tayo ng vertical, we have a vertical na V and P. So, given tayo ng shear stress failure of 120 megapascal, the factor of safety na 2.5. So, shear stress safe is equals to stress fail all over, or factor of safety is equals to 120 all over 2.5 is equals to 48 megapascal. So, shear stress is equals to P all over pi dl is equals to, so apply natin yung 40mm and the 75mm sa ating formula. So, RP is equals to pi 40 times 75 is equals to shear stress safe is equals to 48 megapascal is equals to P all over 9,420. So, RP is equal to 452.160 kilonewton. So, we know that the shear stress is equals to P pi dl. So, is equals to P. Apply ulit natin yung 80mm times 30mm sa ating formula. So, our P all over pi 80 times 30. Our shear stress safe is equals to P all over 7,536 millimeters squared. So, is equals to 48 times 10 raised to negative 6 is equals to our P all over 7,536 millimeters squared. So, therefore, the maximum allowable force P is equal to 361.728 kilonewton. So, for the number 4 problem, so determine the required diameter of a pin at A and B to the nearest 1 over 16 inches. So, if the allowable stress for the materials is 6 KSI, pin A is subjected to double shear, whereas pin B is subjected to single shear. So, we have a diagram na naman ulit dito. We have given a ruler pin, a ruler in a pin connection at A. So, given allowable stress is equals to allowable stress KSI. So, sabi double bound at A and single bound at B. So, getting the required parameters of DA and DB. So, dito first una natin gagawin for easy to us na to understand the given. So, gagawa tayo ng free body diagram. So, we have a given the AY and XY, AX. So, our free body diagram. So, dito, first, magmo-moment tayo. So, sign convention, positive counterclockwise. Moment at A is equals to 0. So, our BY is equals to 12 minus 3 times 8 is equals to 0. So, the result, our BY is equals to 2 kip. So, meron na tayong answer sa pag-moment natin at A. So, kukunin na natin yung f of x. So, sign convention, positive going to the right. Summation of f of x is equals to 0. So negative 3 plus AX is equals to 0. So our AX is equals to 3 kip. So meron na tayong moment at A, summing forces at Fx. Dito naman tayo sa sign convention, positive going up. Summation of f of y is equals to 0. So our by plus ay is equals to 0. Our ay is equals to 2 kip. So dito, getting ba, I use a Pythagorean theorem. So ba is equals to 1/2 the square root of ax squared plus ay squared is equals to 1/2 square root of 2 squared plus 3 squared. Answer is 1.8 kip. So getting VV, so using Pythagorean theorem, the square root of 4 squared plus 3 squared is equals to 5 kip. So applying shear stress, so shear stress is equals to BA all over AA. Pi is equals to 1.8 all over pi dA squared all over 4. So our dA is equals to 0.61814 inches. So meron na tayong dA. So let's proceed to VV. So shear stress is equals to BV. Pi is equals to 5 RVV all over pi all over 4 dV squared. So the result will be dV is equals to 1.061 inches. So for number 5, a spiral gas tank has an inner radius of 1.5 meter if it is subjected to an internal pressure of 300 kilopascal. Determine the required thickness if the maximum normal stress is not to exceed 12 megapascal. So given inner radius of spiral tank, we have a radius of 1.5 meter. So internal pressure in the pressure tank, RP is equals to 300 kilopascal. The maximum normal stress of 12 megapascal. So solution, stress is equals to P times R all over 2 times T. So RT is equals to pressure times radius all over 2 times shear. So here, RT is the required thickness of, so here T is the required thickness. So RT is equals to 300 kilopascal all over 2 times R12 megapascal times 1.5 meter, which are radius, all over 1000 kilopascal all over 1 megapascal. So our kilopascal cancel. So our megapascal cancel also. So we have meron tayong naiwan na meter. So our T is equals to 0.0175 meter times 1000 millimeter all over 1 meter. So convert to millimeter. So cancel meter. We have the result of T. Dahil yun yung hinahanap, ang T, RT is equals to 18.75 millimeter. That's our final answer. So for the number 6, a pressurized spiral tank is made of 0.5 inches thick steel if it is subjected to an internal pressure of 200 psi. Determine its outer radius if the maximum normal stress is not to exceed 15 ksi. So given thickness of pressurized spiral tank is equals to RT is equals to 0.5 inches. The external pressure of 200 psi. The maximum normal stress or our allowable stress is equals to 15 KSI. So solution, allowable stress is equals to P times R all over 2T. So 15 times 10 raised to 3, which is our allowable stress, na 15 times 10 raised to 3 is equals to 200 PSI na ating external pressure all over 2 times our thickness na 0.5. Our R is equals to 75 inches plus 0.5 inches. So in total of our R is equals to 75.5 inches. So for the number 7, air pressure in the cylinder is increased by exerting force 2 kN on the 2 piston. It's having a radius of 45 mm. If the cylinder has a wall thickness of 2 mm, determine the stress in the wall of the cylinder. So given air pressure in the cylinder, we have a P is equals to 2 kN. Radius of each piston, R is equals to 45 mm. The cylinder wall thickness is equals to T is equals to 2 mm. So solution, pressure RP is equals to F all over A. So is equals to 2 times 10 raised to 3 Newton all over pi times 45 squared. Our radius na 45 squared millimeter squared. So RP is equals to 0.314 megapascal. So states of stress, Hope stress, our shear at H is equals to PR all over T. So our PR is equals to 0.314 times 45. Our P is 0.314 kaya yan. So times 45 nating radius all over 2, not T, 2 mm, the thickness. So our shear stress at H is equals to 7.073 megapascal. So for our longitude stress, our shear at L is equals to PR all over 2T. So our PR is 0.314 times 45 na ating radius all over 2 times 2 na sa given formula times T na our cylinder thickness is equals to shear at L is equals to 3.536 megapascal. So for the number 8, a 36 steel band shown below is 2 inches wide and it's secured around the smooth rigid cylinder. If the bolts are tightened so that the tension in them is 400 pounds, determine the normal stress in the bond and the pressure exerted on the cylinder. So given tayo ng tension, F is equals to 40 pounds, the thickness of 1 all over 8 inches, the width of 2 inches. So our radial stress is equals to F all over A. Our F is 400 pounds times 2 all over 2 times 1 all over 8 times 1. So our radial stress is equals to 1,600 PSI. So for B, our hope stress is equals to PR all over T. 1,600 is equals to P times 8 all over 1 all over 8. RP, our Hope stress is equals to 25 psi. So for our strain, the charge in length all over original length. So the charge in length, strain is equals to stress H times pi the R mean, so all over E. So strains is equals to 1600 all over 29 times 10 raised to 6 times pi of S plus 1 all over 16. The strain is equals to 1.3975 times 10 raised to negative 3 inches.